Hi, my name is Gabriel Geiger, and I'm an investigative journalist at Lighthouse Reports and one of the trainers for the Pulitzer Center's AI Spotlight series. This module is going to cover investigating bias, both in more traditional machine learning algorithms deployed by governments and the more modern generative AI deep learning models that are produced often by larger tech companies like OpenAI. We're going to start with this sort of thorny question of what is AI bias. Then we're going to move into a case study focused on ChatGPT and whether it can pass an employment discrimination test. We're going to return to this AI lifecycle we've been discussing in various other modules, but through the lens of bias specifically, or investigating bias. And then lastly, we're going to do an interactive example where we investigate a real-world AI model for bias. So starting with this question of what is bias, it's important to start with this notion that companies and governments promise that AI will be objective and fair. This is a slide from a white paper from Accenture, which is a big multinational consulting firm that built a machine learning welfare fraud detection system for the city of Rotterdam. And you can see that in their sort of promotional material, they promise that advanced analytics plus machine learning is going to equal unbiased citizen outcomes. But the problem with this is that independent watchdogs, civil society, journalists are almost never allowed to test these claims of fairness, of non-discrimination. And in the cases where they have consistently found evidence of bias, oftentimes against the groups in society that are already marginalized. And the question is, why is it that when journalists test these claims, they so often find bias against marginalized groups? And fundamentally, the answer to that is if we train an AI system on biased data, its predictions or behavior will reproduce those biases. But what do we actually mean when we say an AI system is biased? The reason that I'm bringing this up is because to some extent, all predictive AI systems are biased because their job is to sort of take a training data set and generalize off of it. All AI systems will use different variables and in some sense, therefore, be biased against those variables or categories. An AI system may use a variable like in an earlier example in this training series, the width of a tree trunk to predict the age of a tree. But that doesn't necessarily mean that the AI system is sort of biased against tree trunks that are wider in a problematic way. We sort of get down to this fundamental question, which is that, there's sort of all AI systems are biased to some extent, but when is bias problematic? The question, is a model that uses age to predict the risk of cancer biased? Is a model that uses whether someone smokes to predict the risk of lung cancer biased? There's some cases where bias might seem uncontroversially not problematic, and then there's other cases that might be more gray area, and then there's other cases where arguably bias becomes very problematic, like using personal characteristics about people to predict whether they're going to commit a crime in the future. So with that said, we're going to start with a case study here focused on ChatGPT. The sort of important starting point here is that AI doesn't exist in isolation. Analog ethical standards also apply to AI ethical standards. So what is fair in the sort of non-technical, non-AI world also should be what's fair in the sort of world AI ethical standards. And what that kind of means, and this is going to sound abstract, but I'm going to sort of explain what this means in further detail in a second, is that we can use our sort of analog ethical norms to interrogate machine learning systems. Again, this is going to sound abstract, but I think when I break it down, it's going to make a bit more sense. Let's start with employment discrimination. Again, nothing related to AI, just employment discrimination in the sort of real human world, quote unquote. Employment discrimination is basically when people who are equally qualified for a job are not hired because of their race, their gender, their age, or some other protected characteristic. Age-old study when academics want to try to study or quantify employment discrimination in the analog world. And basically the design of the study goes like, you take the same CV or the same resume, so the past work experience, everything is the same, and then you only change the name on it to some racially distinct name or ethnically distinct name, and then you sort of see who gets called back. And the result, time and time again, when academics have conducted this study, not just in the United States, but in a number of different countries, is that resumes or CVs with racially distinct names receive less callbacks for a job, despite having the exact same resume. So then there's this question that we could ask, okay, we've seen that this study has been done a number of times when it comes to human recruiting. So we could ask this question, well, could ChatGPT pass this same employment discrimination test? What if we tested ChatGPT the same way? We take the same analog test that academics have done, time and time again, but now with ChatGPT. So we asked ChatGPT to rank the exact same CV or resumes, but with different racially distinct names. And that's exactly what a team of journalists at Bloomberg did. So they figured out that companies were trying to sell generative AI recruiting software to rank people's CVs or resumes. And so they conducted the same academic experiment where they fed ChatGPT the same CVs, only changing the name to different racially distinct names in a US context, and found that indeed, also with ChatGPT, there was big differences just by changing the name in how it would rank CVs. So for certain jobs, for example, CVs with racially distinct names of black men, ChatGPT would rank them lower compared to, for example, white men or white women. And sort of why does this matter? Well, the share of Americans that say that AI would do a better job than humans at treating job applicants the same way is nearly 50%. So nearly half the population in the United States believes that AI would be better than humans at treating job applicants fairly. Now we're going to move into how we investigate AI bias, and we're going to sort of frame it again into the AI life cycle that we've been discussing in previous modules. At what points in this AI lifecycle of data, compute, model, and application can bias arise? Take a minute, scribble some stuff down on a notepad or on your laptop, and pause this video and see what comes out of that. What you're looking at in front of you is a version of this AI lifecycle that we've been discussing, but in a bit more of a technical way, so we can thinking about specifically interrogating AI bias. So we're going to sort of go through bit by bit and talk about the different questions you can ask or how bias can arise. So first you have the input variables of a model. So this is actually whatever the AI model uses to make its decision or make a prediction or classify something. So for example, you could ask here, does an AI system use variables that are potentially unfair, like a person's race or gender? Or does it use variables that are related or correlated with those things, like postcode or zip code, for example? Then you have the actual training data itself. So this is the training data that the model actually learns from. And then you could ask, does that training data contain historical biases? Is it representative of the real world? So for example, criminal justice data in a US context may contain historical biases or sort of patterns of racialized policing that are sort of inherent in that data. Or in the case of a facial recognition data set, maybe it isn't representative of the real world. Maybe there are more faces of men than women, or maybe there are more white faces than darker skin tone faces. Then you have the actual model type. Is the actual machine learning technique sort of inject randomness or bias, or is it sort of difficult to understand? Is it a black box, like some of these more deep learning neural network algorithms that we've been discussing previously? That's another thing you can ask. Then you can ask, okay, accuracy. Does the system perform equally well across different groups? Classic example here, again, is facial recognition algorithms, where it's been sort of well documented that facial recognition algorithms oftentimes perform less well on darker skin tones compared to lighter skin tones. Then you have sort of the actual outcomes. So is there disparate impact against vulnerable groups? Are women more likely to be selected by an algorithm than men, or classified a certain way than men? And then the last one, which is I think really important always, is the application of an AI system in of itself biased in some way? So is the actual premise of the AI system actually biased? And sort of a key example in my own work that's come up, often focusing on AI deployed in welfare systems, is that the amount of technology and AI and sort of machine learning that's thrown at uncovering small-scale welfare fraud compared to white-collar tax fraud is immense, and there's a sort of inescapable contrast there. So, this is a sort of like bigger picture question of whether a system might be biased, or the premise of it might be biased in some way. A quick note here, oftentimes you'll see vendors of AI systems or governments say that their system isn't biased because they avoid using sensitive characteristics like race or gender or ethnicity. But what you'll often see is that they'll use instead proxy variables for those characteristics. So in other words, variables or data that approximate something that's sensitive or is correlated with something that is sensitive like race. So for example, really common proxies that you'll see for race or ethnicity are things like postcode/zip code or last name or even household composition. So a model may avoid using those things, race or ethnicity directly, but oftentimes will use stuff like this. So what types of materials actually enable us to test for bias? So if we want to investigate an AI system for bias, how do we actually do that? So there's a few different routes there. So the first one is, okay, you can obtain access somehow to a model and test it yourself. If that's a government algorithm, like a predictive policing system, that might be a really involved, difficult process to access a model. When it comes to generative AI, like ChatGPT or Claude, the model itself, as we've been discussing, is so complex and has so many parameters and is sort of intellectual property that you won't be able to probably, and requires so much computing power to even run, that probably you won't be able to access it in that sense. But what you can do is, of course, test the model as a black box. So you just ask it to do something and log the results, similar to the Bloomberg piece that I just discussed, right? They didn't have access, sort of back-end access to ChatGPT, but what they could do is ask it to rank resumes and log the results of how it did that. The other things you can look for are internal reports. So governments and companies increasingly audit their own models for bias. You can try to obtain the results of that auditing. You can try to do a more bottom-up approach. So you could work with communities to crowdsource data and testimonies. Classic example that we've discussed in these sessions of that is Varsha Bansal's stories about Uber drivers being locked out because of faulty facial recognition systems. So there she crowdsourced data with a survey. And then lastly, working with academics can be a great way to sort of figure out unique methodologies, or academics may have the ability or already have access to exclusive data that companies or governments may not disclose to journalists. Okay, so with that said, we're going to talk about a few different ways of thinking about AI bias. Again, this is talking about AI bias in a very technical sense of the word. So it's important to sort of familiarize yourself with the way that computer scientists or people in a more tech-focused space oftentimes think about AI bias. So you're sort of fluent in that language, and that can sort of shape the way that you yourself investigate AI bias, or you can sort of understand the discussions that are happening within more technical spaces about AI bias. So one way of thinking about AI bias is sort of simple over or under representation. So a system is unfair if a group is over or underrepresented in AI systems predictions. So for example, an AI system that disproportionately selects women for fraud investigations is biased under this way of thinking about bias. Another way of thinking about AI bias is that it should sort of perform equally well across different groups. So again, I've talked about a few times, but the classic example would be a facial recognition system is only fair if it can perform equally well on darker skin tones and lighter skin tones. And then the last one is around the errors that an AI system makes, and that these errors should be equally distributed across groups. An example here would be an AI system that wrongly predicts black defendants will be future criminals in comparison to white defendants is biased. And that's the sort of way of thinking about bias that ProPublica used in this machine bias piece that we talked about in an earlier module. And it's sort of important to keep in mind that oftentimes these debates around AI bias are not always that straightforward. So, for example, in the wake of this ProPublica piece that determined this risk prediction software used in court systems in the US was more likely to wrongly predict that black defendants would go on to commit another crime, after that piece was published, the company that made this software argued that according to another way of thinking about fairness, another fairness definition, the system actually was completely fine and treated black and white defendants equally. When academics looked at this debate, they found that these two definitions of fairness, these two mathematical notions of fairness, were actually incompatible with one another. So you can't satisfy both or make it fair in both ways at the same time. And this has sort of given rise to this debate within the academic community about which mathematical definition of fairness is correct, or under what circumstances is it correct, and what does it sort of mean that different mathematical notions of fairness can't be met at the same time. This is a sort of running debate that it's important, I think, to be aware of if you are going to be sort of investigating AI systems for bias. With that said, the sort of ironic end results of this debate about AI, mathematical debate about AI fairness, is that there sort of is no correct answer. There is no mathematical fairness definition that every academic has settled on, oh, that's the correct one that we should be using. And what that means is AI bias is ultimately about context, and that's something that you've hopefully defined in your reporting. So this line from the Machine Bias ProPublica piece is always something that I return to because it's about a deeper sense of fairness beyond mathematical definitions or statistical definitions of fairness, which is scores like this, known as risk assessments, are increasingly common in courtrooms across the nation. They're used to inform decisions about who can be set free at every stage of the criminal justice system, from assigning bond amounts, as is in the case of Fort Lauderdale, to even more fundamental decisions about defendants' freedoms. This is the sort of larger thrust or deeper question about fairness that's raised by Machine Bias and by ProPublica's investigation, which is it okay to use predictive modeling, predictive AI that generalize based off of data in the past to make decisions about people in the present? And that's a sort of important part of your reporting, and that sort of deeper question that I think needs to drive investigations about AI bias. All right, we've arrived at the final part of this module, which is going to be quick and fun, interactive exercise investigating a real AI model for bias. This is a real system that I investigated in the city of Rotterdam, and this is an AI system that attempts to predict which welfare benefits recipients are committing fraud. And to do that, this predictive system assigns every person who receives welfare in the city a risk score between 0 and 1, with 1 being the highest risk of fraud. And the system uses, in order to calculate that risk score, uses 315 input variables from each person, including the language they speak, their gender, their age. And the system was trained on data from past investigations the city has carried out on welfare recipients. The question to you all is there any red flags here? Maybe pause this video and write down all the red flags that you see on a notebook or on your laptop. Many red flags here, but one of the most important of them is the training data. So the system is trained on data from past investigations the city has carried out on welfare recipients. And the sort of fundamental fact here is that if those past investigations that the city carried out were biased against certain groups of welfare recipients, then the model is likely to exhibit those same types of bias. And so let's investigate the training data. For our investigation, we were able to obtain the training data. And what you see on this graph on the right side of your screen is the distribution of people of different ages in the real world. So this is a representative random sample of welfare recipients. And then the distribution of welfare recipients in the training data used to train this model. Do you notice anything? One thing that I notice is that in the yellow bars, which is the training data, there's hardly any people below the age of 27, whereas in the real world, amongst actual welfare recipients in Rotterdam, sort of representative, there's far more people below the age of 27. So young people are vastly underrepresented in the training data used to train this model. Just showing it even closer here, again, the blue bar is the real world distribution of young welfare recipients below the age of 27. The orange bar is the training data used to train the model. And we see that young people are vastly underrepresented. So then we can ask, is the model somehow biased against young people? Is this sort of skew in the training data something that produces a model that somehow is biased against young people? Don't get too distracted by the graph, but basically this red area is this sort of high-risk group that's selected by the model. And this blue line that sort of curves up at the very, that hits the very top is people under, 25 and under. And you can see that young people are vastly overrepresented in the high-risk group that is selected by this model as a potential fraudster. So, to sort of sum this up, to this algorithm, to the model, it appeared as if young people were more likely to commit welfare fraud, but it drew that conclusion based off of a sample in the training data that was so small that it was effectively useless. So in the training data, there was maybe 50 young people, if I remember correctly, and it should have been hundreds if it was going to be representative. If you have some time, you can pause on this slide and check gender and see if there's anything there. That's the end of this module. If you want to sort of dive further into how you investigate bias, I've included some good reporting examples at the top and some methodologies of different organizations that have talked about technically how they approached auditing machine learning or deep learning systems for bias. And lastly, a set of sort of academic articles on this topic. Thanks very much, and looking forward to seeing you in the next module.